Here is the next example. In this example, he's asking us to find the voltage across capacitor VC. Okay, he gave us 0.5 Henry, 25 millifarad. The mutual inductance is 0.2 Henry and 1 Henry and 5 ohms. And the voltage is 12 cos 10t. Okay, so this is look like V max cos omega t. So the given value is maximum value. You need to convert that given value into RMS value, which is V max over square root 2, 12 over square root 2, which is 8.48. And then if it doesn't have anything 10t, you can put plus 0, so 8.48 at an angle of 0 volt. That's the voltage. Okay, you don't need to convert this cos into sine or sine into cos. Just leave it as it is. Then in the answer, whenever we're finding VC, you're going to write VC equal to V max, whatever that value is, cos, okay, cos omega t. Omega is 10t, so it's going omega equal to 10, so V max cos 10t. That's how we're going to write it down. If it is sine, I'm going to write V max sine 10t. So you don't need to convert sine into cos, cos into sine. Now I'm going to take this as L1, this as L2, and J minus JXC, this is JXM. So it's going to be JXL1 equal to J omega L1. Omega is 10. Okay, that indicates the omega. So JXL1 equal to J5 ohms, JXL2 equal to J10 ohms, JXM equal to J2 ohms, minus JX equal to minus J4 ohms. Now this circuit is frequency domain. Now we can simply apply KVL and KCL. If it is in time domain, then you will end up having di by dt or dv by dt or something like that. So to avoid the differential equation, what we're doing, we're converting a time domain circuit into frequency domain. So loop 1, apply KVL. So when you apply KVL in loop 1, minus 8.48 at an angle of 0 plus V1 is nothing but J5 times I1 plus minus J4 times I1 minus I2 equal to 0. Most of the time we'll put 0. Okay, it's not true because here we have mutual inductance. So the mutual inductance is nothing but because of the current flowing in this coil, which is I2. Because of I2, there is an induced EMF there. So current is entering the dot, so the dotted terminal must be plus. So we'll end up with plus there, minus here, that value is E1. What is E1? E1 equal to J2 times I2. So this value is J2 times I2. Now, so are we going to add this or subtract this? Both the signs are in the same direction, so we're going to add that one too. So plus J2 I2 equal to 0. So when I simplify this, J5 minus J4, which is J1, minus J4 times minus I2 plus J4, so plus J6 I2 equal to 8.48 at an angle of 0. This is my equation 1. Now I'm going to do loop 2. Loop 2, apply KVL. If I apply KVL here, according to my current direction, this is plus minus, plus minus, plus minus. Okay, I'm going to follow the I2 direction. Now the mutual inductance. Because of the current flowing here, there is an induced EMF. That induced EMF is plus here, minus there, which is E2. Okay, now E2 equal to J2 times I1. Okay, so I'm going to write down the first, the regular voltages or voltage drops or gains, which is J10 I2 plus 5 I2 plus minus J4 times I2 minus I1. Okay, now are we going to add E2 or subtract E2? Here I'm going to add E2 because both of them have the same sign. Our voltage drop here, say VA, VB, VC. So our VA and E2 both have the same signs, or the sign is on the same side. So you must add that J2 I1 equal to 0. So this value is J6 I1 plus 5 plus J6 I2 equal to 0. I mean J10 I2 minus J4 I2 will become plus J6 I2. Okay, this is my second equation. So I have two equations, two unknowns. Find those. Now if you follow your textbook is going to do it's a little bit different way. I will write down the equations and then I'll solve for these equations. So your textbook, if you follow your textbook, look at this circuit. I'm going to redraw the circuit. So here is the given circuit. What your textbook did, so you have a mutual inductance, right? So I'm assuming I2 current is passing through this and I1 current is passing through this. Because of I1 there is an induced voltage here. That voltage I'm going to indicate that first, plus or minus, let me say E2. I mean plus and minus, not plus or minus. E2 equal to why did I put the plus here first? I1 is entering the dot, so the dot terminal must be plus, so that's how I chose this plus. E2 equal to, can I say J2 times I1? Okay, so this is a voltage, and okay, this is in volt. So this voltage, can I say it is a current dependent voltage source? Okay, in the same way I'm going to indicate the voltage here. Let me take that as E1. So current is I2 is entering the dot, so the dotted terminal must be plus, so I'm going to have plus there, minus here. I'm going to label this as E1. What is this E1? Equal to J2 times I2. Now once I have the E1 and E2, what I'm going to do, I'm going to replace these dots and the mutual inductance with a dependent source. So what I'm going to do, I'm going to replace this with E1. Okay, which side is plus? This side is plus, here is minus. This is J2 I2. Okay, and I have capacitance, and here I have plus and minus E2, which is J2 I1, J10 ohms, J5 ohms, 8.48 volts at an angle of 0. Okay, and 5 ohms. Now I don't have these dots and the arrow. Okay, that one is replaced by a dependent source. Okay, so it doesn't matter where do I put this dependent source. I can put it here, I can put it right here. It doesn't matter, both of them are the same. But make sure always the left hand side terminal is positive. Same thing here, I can put it there or I can put it here, but make sure the left hand side terminal has positive. Okay, so now it's easy for me to apply KVL. So here is my loop 1. So I'm going to take that as I1, loop 2, I2. Okay, so if I take loop 1 I1, so plus and minus, it's already given, plus and minus. So minus 8.48 at an angle of 0 plus J5 I1 plus J2 I2 plus minus J4 times I1 minus I2 equal to 0. This is my first equation. So if I simplify this, plus J5 I1 minus J4 I1, which is J1 I1 plus J2 I2 minus of J4 minus I2, which is plus J4 I2 plus J2. So J6 I2 equal to 8.48 at an angle of 0. This is our first equation. If you look into the first equation, it must be the same here. J1 I1 plus J6 I2 equal to 8.48 at an angle of 0. Now this is loop 1. apply KVL. Now loop 2, same thing, apply KVL. So according to my current direction, this is plus minus plus minus plus minus. Okay, let me use different color. So here I'm entering the positive terminal, so J2 I1 plus J10 I2 plus 5 I2 minus J4, or I can say plus minus J4 I2 minus I1 equal to 0. So I included everything. The mutual inductance is right here. So if I simplify this, J2 I1 plus J4, so plus J6 I1 plus 5 plus J10 and minus J4, so 5 plus J6 I2 equal to 0. So here is my second equation. Now I have two equations, two unknowns. So if you look at the second equation, I have the same thing, J6 I1 plus 5 plus J6 I2 equal to 0. Now we have two unknowns, two equations. Let me solve this. So to eliminate I1, what I'm going to do, I'm going to multiply this with 6. Okay, equation 1. So it's going to be J6 I1 plus J36 I2 equal to 8.6 times 8.48. That value is 50.88 at an angle of 0. The second equation, I have J6 I1 plus 5 plus J6 I2 equal to 0. I'm going to subtract these two equations. So this is plus, it will end up with minus. So it's going to be minus 5 plus J30 I2 equal to 50 at an 50.88 at an angle of 0. Okay, so if I take my I2 equal to 50.88, what I'm going to do, let me keep this as negative I2. So if I put this as negative I2, so what I did, I pulled the negative outside, so it's going to be 5 minus J30. So negative I2 equal to 50.88 over, so 5 minus J30 is nothing but 30.41 at an angle of minus 80.53. So minus I2 equal to 1.673 at an angle of 80.53 degrees. So you can write it down, I2 equal to negative 1.673 at an angle of 80.53 degrees. This is our I2. Our goal is finding the voltage drop across capacitor. So I need I1 and I2. So what I'm going to do, I'm going to substitute this I2 value in any one of the equation. So let me substitute this I2 value right here in the second equation. So in the second equation, I have J6 I1 plus 5 plus J6 I2 equal to 0. So I'm going to substitute I2 value there. So J6 I1 plus 5 plus J6 times negative 1.673 at an angle of 80.53 equal to 0. Okay, once you find I2, I substituted I2 value in equation 2. Okay, I2 is minus 1.673 at an angle of 80.53. I'm not sure whether I explained I2 or not. So this is how I solved I2 two equations. I cancel I1, so I end up with minus 5. So I'll end up with minus there. So minus 5 minus J6 plus J36. So minus 5 plus J30 I2 equal to 50.88 at an angle of 0. So I pulled out minus. So it's going to be 5 minus J30. So basically what I did, if I pull the minus, 5 minus J30. Okay, that's what. So minus I2, I keep the minus there. 5 minus J30 move to the denominator. So I end up finding I2 equal to minus 1.673 at an angle of 80.53. I substituted that value in equation 2 and solved for I1, end up with I1 equal to 2.177 at an angle of 40.73. our goal is finding VC. To find VC equal to minus J4 times I1 minus I2. That's the voltage drop across capacitor. So I1 2.177 at an angle of 40.72, I2 is minus 1.673 at an angle of 80.53. So minus of minus will become positive. Okay, convert that into rectangular format. 1.65 plus J 1.42 plus 0.275 plus J 1.65. Add them together, end up with 3.62 at an angle of 57.91. VC equal to minus J4 times I1 minus I2. That's VC. So end up, so this is in RMS value in frequency domain. Convert that into time domain. When you convert that into time domain, it's 20.47 cos 10t minus 32.09. Okay, that's our VC. Okay, I will stop this video here. Next video I'll solve for the I'll solve next example. Thank you.